Starter bar, right? Starter bar, huh? Okay. Yeah, if you say here, then you have to follow the same terminology. Then you have to follow the same terminology. It is all same, right? The funda is same, right? It is in the beam, okay. And LD also here it is same, right? Then how much you will follow? The question is clear, right? The question. I'm not here to talk about the lapping, huh? Lapping बाद में आएंगे. Lapping और एक scenario है. Now we will only concentrate on the developmental terms. Okay. This is a generalized 50 times of diameter. If you say 2.5, at least it makes sense. Say for an example, my starter bar is actually 25 millimeter there. Okay. So 50 times of 25 millimeter, how much? 1.25. Or do we need to follow 1.25 criteria? Or is there any criteria is there? Or do we need to take it as the whole LH, which is 4.5 minus the cover or something? Let's take it 200 millimeters. Okay, layers, covers, everything. Let's take it 200 millimeters. So 4.3 plus the L is what? Minimum 300 to 400 you will follow, right? Minimum 300. So 4.3 plus 300, 4.6 meters. How much rebar are you going to waste? Do you think the consultant will show all those things? He will not show. He is very clever. Huh? The consultant actually is very clever. Rather, he will not show the reinforcement in the general details at all. He will show only the, what do you call, the concrete section. He is very clever. Okay, our question. This question actually does not finish. Huh? Let me go for another question. Difference is what? That is considered as area element. This is considered as a frame element. So here you are going for as a ties. There you are going as a horizontal ring. So both are it is a shear reinforcement. Correct? Both is going to be compensating shear voltage. What is the spacing? Let's assume 100 millimeters. What is the diameters? Let's go for 12. Okay, because we're talking about the towers actually, especially like the ground floor will have a huge shear. So at least at 3-4 floors, I mean, you will have like 12 millimeters or sometimes 16 also. But let us not talk about. Let us not exaggerate 16. Let's go for 12. I'm talking about the tower. I'm not talking about the small buildings. Okay, 12 is as usual. For us, the shear wall 12 is usual. Yeah, because sometimes the main bar itself it will go to 32 millimeter, 40 millimeters. Correct? 40 bundle bar, bundle 40 bar. Do we need to follow the same 12? We're supposed to follow, right? In that case. This is another question. Another question I finished from that. This is another question. Do we need to follow the same spacing, same diameters?
Spacing and increased.
No need.
But this is a vague answer, right? Spacing you can increase. I can even give you 300. I can give you even 400. I can give you 450 as well. Another thing is what? Lapping. Yeah? Okay. 50 times of diameter. OB standard. Yeah? OB people are using standard. Someone kept the standard actually they follow. Is there any correlation? Development length and splice. I'll give you the answer. Think about it actually. Okay, for half an hour, 1 hour. But before end of session, I will give you the answer. To such a very basic something which you will get in the examination. Either you talk about G+4, G+4 unlimited achievement. If I'm the one who is going to be like conduct the interview, the who wanted to like come in for a job as a designer, so I'll ask this question. I'm not going to ask you like design the A.E.X.L model. Prepare this. I'll ask you only 3 questions. Draw the reinforcement detail for staircase. If someone knows the behavior of the staircase, he can immediately draw it. But you need to understand the behavior. The second one is actually development plane. Third is splice plane. Fourth is the horizontal reinforcement. Joey Pucha, these 3-4 questions, it is all related to technical. You cannot give the vague answer here at all. You cannot. You may say 50 times of diameters. Only those answers. But other than that, you cannot give you like 47, 48, 49. No correlation. 50 it makes sense somehow because people are following 50 times of diameter actually. At least like people fond of to listen like okay 50 times of diameter. People are using it. But other numbers you cannot even use it. Okay. 3, 4 basic questions. Okay. Let's move on. ये note कर लो. Just note this 3, 4 questions. Okay. I will get back to you. Anchoring length will be for the what do you call the bolt, or if you miss the rebar from the continuous slabs or continuous beam, then you need to what do you call. Again, anchoring length is called as development length. See, development length क्या है? वो भी anchoring length है. Because what is development? What is anchoring? What is development? Why we need it actually? Why we have to maintain certain criteria? 40 times of diameter, 50. Why?
To develop the bond.
What?
To develop the bond between.
To develop the bonding between the concrete to steel. Anchoring away from that. The funda remains same. You are going to develop the bonding between the concrete and steel. Tension, of course. Bonding हो गया ना, bonding. Why you are checking? Because of tension, right? Right? If it is a compression, then I'm not going to use like 50 times of diameter, whatever you said, like the general. So I will use it less than that. In compression also, then you will have used it 50 times of diameter. For me, it is critical is tension, right? Yeah. The one which you are talking about, if you forget the rebar for the continuous slab, then I need to calculate the precise, what do you call it, the load to go for it, because while going for post-fixing by using chemical, I cannot go for like the longer development length, as you say 50 times. So what happened by using the chemical, and with the chemical, with the rebar actually I will calculate precise gauge. So their chemical also will be like for this way to take care of it. That's the reason you will see 150 millimeters, 200 millimeters, whereas in reality it will be 600, 800. So sometimes if you are using post-fixing, it is only required for 300, 250. You cannot really even 300 also. It's very difficult. Side they knows the difficulty. The 30 centi also it is very difficult to drill it, right? 15, 20, I believe, 20 centi is okay to drill it actually. Yeah. And you will have so many constraints. Rebar will be there actually. You will touch the rebar, then you have to scan it. So many things are there. Okay. It's not easy. I'll remove this, huh? Yeah. What is this? Chair bar, right? Chair bar. There is any calculation for chair bar? Or we just randomly will go for okay, 1 square meter, 1 chair bar. It's very least importance actually. In fact, it's the least importance, correct? Very least importance.
Very critical because most of the time the chair will collapse.
Yeah. Because we are relying on the foreman, right? For my machine only, I need to check the diameter and spacing. Chair, if it is not the one which I don't know, what I'm going to say, I will blame the foreman. What? And I'm just keeping my foot. Actually, it is bending me. Or a chair. Because you did not inform me technically. Correct? Isn't it? Actually? Correct? Okay. 4 to simply supported, yeah, simply supported, having the load of W kilonewton meter, the span of which is L. Okay. Assume this is the concrete beam. This is the concrete beam. We have a concrete support. Concrete support. So I'm going to design this concrete beam. Okay. All you can interact. No problem. Even if it is wrong, it is fine. To design this concrete beam, either you can call it as a design step, also design principle, okay, design criteria, whatsoever you want, you can call it as. But ultimately, I need to design this concrete beam. Correct? What are all things which is required? There's 1 week gap. I wanted to just spark your interest. Yeah? Question is clear, right? To design this concrete beam, as a designer, what are all the things which is required?
First we count. Assume the depth.
Assume the
Depth.
yeah. Assume the depth. Yeah.
Span by 20.
Assume the depth. Anything else? Loads. Then
Grade of concrete.
grade of concrete. Okay. Then grade of steel. Grade of steel. If you are using high grade of concrete, will it have any impact in the development line?
Yeah.
Will it reduce? Will it increase?
Reduce.
Because if I increase the high grade of concrete, definitely the development line will increase, right? Will reduce, right? Correct? Yeah. But if you see most of the general notes, they might have combined the diameter saying from 10 millimeter to 20, you have to follow this development. From 25 to 30, you have to follow this development. Okay? It's not that. From 10 to 25, it's a huge difference. Might be 10 to 12 is okay. If you're going for 16, might it get reduced with the grade of concrete. If you're going for 20, if you're using high grade of concrete, it will still reduce. If you're going for 25 with the high grade of concrete, it will reduce further. Every point. The consultant is very clever. Okay. There are two types of contract, right? One is lump sum contract, another one is remeasurable contract, right? If it is a lump sum, yeah. If you don't read the general details and general notes properly, plus you need to keep all your money in front actually to execute the further construction, correct? Because you did not read the general details. Kidhar bhi nahi rahe. Development plan, it will be only there in the general details. Other than that, you will not find any drawings. 90%. Maybe 10% actually, bit of to help to the contractors actually. Might have some consultant will place it actually in drawings. But it is very rare case. So most of them you will find it in the general notes and general details, correct? Okay. Coming back to the question here. Grade of concrete and grade of steel. Further. Anything? Section sizes. Now I am going to write it as it is. I'm only dictator. I'm going to consider you as a dictator. I'm going to write it as it is. I'm not going to change anything. As it is. Just interact. Even if it is wrong, doesn't matter. Na? जब से जाएगी hi hello करके जो बस काफी कुछ. Okay. Nobody knows. You're all here to design it. We finished almost steel, connection design. We have seen the stack approach. I'm asking the simple question. Okay. So I'm not a designer. To answer this, you don't need to be as a designer. To answer this, you don't need to be as a designer. When you need a designer, when I say give me the basic shear or base shear for the seasoning, it makes sense. Give me the actual dynamic force for the wind, then it makes sense. I didn't ask you that. I asked you a very simple question. I don't need any equation. Equation nature or formula nature, kuch bhi nature. To design this concrete beam, what are all the design steps? Is it? Depth. Length.
Loads.
Someone said here.
No, loads already there.
Moment. You're all missing something. I'll tell you what it is. Because your interpretation, my interpretation is different. Okay. What you all concentrating actually, what I asked the question, suddenly you went for what are all the steps is required. No one is coming to the core point actually, what is finally is required. Yeah? What is it? Area of steel, right? A.E.X.L. Plus this is more than enough. You don't need to do all those things. You're getting a point. This one step is okay to come up with all your things. Now what happened? You keep on remembering one by one you are giving the answer, correct actually? This itself you can be answered like all those things. Okay. Let's go further. What else? Anything? Anything? Because I don't want to equal. Disappoint you. Tell me anything further. Anything further? A.E.X.L then? Loads. Huh? Limit state. Okay. LSM. You know limit state, right? LSM. It's one of the methodology in order to do the analysis. LSM. Shear. Then shear. We'll finish shear. At least 15 points. 3 more points. Shear. Anything. Displacement. Or Bahubali 4. Bahubali 3 and the direct displacement rotor. I just applied gravity load. He said due to wind directly. Interesting. Displacement. Bahubali 4. Part 4. It's fine. I'll write it. As long as you understand what is displacement, that is good enough. You did not say as randomly displacement. As long as you understand, it's fantastic. Yeah. Anything. With no point. Drift. This Bahubali 6. The Bahubali 6. That is wind actually. This is due to seismic. I did not even talk about it. Fantastic. No problem. Fantastic. राजमौली है ना पुणे डायरेक्टर अब वो सुनेगा वो परेशान है अभी 3 नहीं उठाया it come 4 and 5 and 6 अच्छी है deflection अभी राइट को आया actually deflection okay I'll just reformulate but I'll give you the core answer what it is the moment when I say okay to design this concrete beam again what is required actually I need the final section sizes and the rebar. So look at the core actually, whatever it is. If it is a steel beam, I need the size of the steel beam, right? And at the same time, I need the grade of steel, what exactly I'm doing. This is what ultimate, whatever you do, whatever you want to apply the load actually, dead load, gravity load, live load, seismic load, wind load, whatsoever you want to apply temperature load, you apply it. But finally, I need the section sizes, I need the grade, right? Actually. Here also finally what I need actually, in order to cast, in order to go for execution, I need to inform someone use this grade, right? Use this grade of steel, use this grade of concrete, right? And at the same time, I need to give the precise sizes, right? And of course, I need to give you the reinforcement as it is. So let's talk about the reinforcement actually. What does it mean? M by 0.95 Fy. Okay. So to give it to someone actually, definitely this two has been already covered, right? Grade of concrete, grade of steel. Now going back to the section sizes. Section sizes इसमें आ गया 0.89 D effective. So I need D effective, correct? Which is I need overall depth. उसमें आ गया. Then what else? See grade of steel भी आ गया इसमें, correct? Then what else? The unknown is what? M, right? Same is what? Same. With respect to anything, with respect to like fixed beam, simply supported, the equation will get changed, right? इसमें क्या हो गया unknown? W is done. You don't need to recall what I'm trying to say. I don't know whether some people are recalling or remembering or very hard to pull all those steps actually. No, you don't need to do what I'm trying to say. You don't need to do actually. You don't need to do all those things. It's a very easy way to do that. Anything which you want to calculate finally, just try to go into the very core. What I need actually. In that, what is the unknown? How to calculate. That's it. If you come up with this, I'm telling you, even for your manual calculation, anything actually, you will not stuck anywhere. You will never stuck anywhere. This is the one of the tip to just easily crack this whatsoever you say the further examination. I don't want to give you the name, whatsoever you say is the further examination. This is one of the tip. The people are only lacking, wasting the time actually because they want to come from. When it is required, when I am there in academy, it is required actually. I'm not in academic. Just come. You're getting a point. What I need now, actually, I need directly. From there, if you go, actually, it will be easy for you. You're getting a point. Just giving like easy way. Because in academic, if you don't follow the steps, actually, you will not get the marks, right? Actually. I cannot go directly from A.E.X.L, from academic, right? Actually. But here it is not like that. Follow me now, what I'm trying to say. I'll reformulate this for your easy way. Okay. I'll reformulate this. Okay. The one is what? Materials, right? The materials which is go for what? Concrete, steel. Fantastic. What is the minimum grade of concrete? 30 actually.
30 to 40.
Huh?
40.
40. 40 is cubical or cylindrical?
Cubical.
Cubical. Then cylindrical will be?
32.
30. What is the correlation?
0.8.
Whatever it is, 20% you say, 80% you say. Like he said, actually 1.25. Yeah? he brought up some other ratio. Right? Okay. Grade of steel? 460, 500, 550, whatsoever there in the market, you can use it. It doesn't matter actually. Okay. Second one. So far, I'll go for 500. Anything if you're writing, actually, don't write without the units. Huh? Okay. If you don't know the units, actually, don't go further steps. This is this step wise actually. Okay. Clear the units first, then go for the next one. Huh? MPa. Okay. MPa and even per millimeter square both are same, right? Fantastic. The second is what? Section sizes, right? Section sizes. The moment when you're talking about the beams, okay, very practical, huh? Will not go as per code, okay, because now you are going to do the real design, right? Real design, okay. Span by 9 to 10. What is span by 9 to 10? To define the overall depth of the beam. You can go for span by 9 or span by 10. Okay. Span by 9 is bit optimum, right? Span by 10 is bit optimum, correct? If it is 8 meters actually, divided by 10, 800 millimeters, right? If you divide it by 9, how much you get it? 850 something. So go with span by 10 inch. Okay, span by 9 if you do have higher loadage. You do a higher loadage. Okay. But remember one thing. It's not about like to propose the reduction in the beam depth. Okay. If you want to reduce the beam depth actually, there won't be any kind of magic. You need to compensate with the reinforcement. Okay, it's a very simple funda. Okay. If you don't want to increase for another 10 centimeters or 5 centimeters, if you're thinking like you're going to waste the money actually, you're going to waste like 2 times higher than the money in the competition, in the steel as well. Okay. So don't think that this 5 centimeter, 7 centimeter, 10 centimeters. Okay. Sometimes design will pass actually. It will not pass in the deflection as well, which is serviceability criteria. Okay. That's what we said moment of inertia, right? How about the third one? Second, I'll make it very clear. Okay. Further, for your reference, the columns as per authority requirements. You know how many authorities are there? I don't want to talk about you. But still, for your reference, DM, DDA, 30s in Dubai. Okay. DDA and DM actually, it's not a what do you call mandate rules, but they just what do you call given a verbal confirmation that we should not use not less than 250 millimeter of width of columns, even for a villas. Before they were accepting 200, but now sometimes actually like there are some of the engineers who will like keeping a different kind of opinions, so they want to go for not less than 250 millimeter width. I'm talking about the villas. Okay, they were rejecting the points. It depends actually on the engineers. But still, I will write it 200 to 250. Okay, 200 to 250. Going with wall, again, the minimum will be 200 to 250. The wall thickness, 200 to 250. Okay. Going with slabs, span by. Span by 35 to 36. More practical. Okay, because we are going to design the live project. Okay, with the live project. We are going to design the live project. Span by 35 to 36, which is defining the thickness of the slab. Overall thickness of this slab. Anything, it doesn't matter actually. Either it is precast or it is a normal structure, which is like casting sheet. Okay. The precast, the one is exceptional for if you are not using tendons. If you are using tendons actually, okay, then the thickness it goes further reduced. Okay, further reduced. This is for traditional casting sheet. Don't confuse yourself. Okay. Foundation. The minimum thickness according to the code is 250 millimeters. But in practical, we are not using 250 actually. We are using what? 36, 300 millimeters, right? Because we do have cover constraints. The clear cover is 75, and having with the rebar, we need the minimum distance between the bars. It's clear, right? What else? We do have only these elements, right? Columns, beams, walls, slabs, and foundation. Third one is what? Loads, right? Third one is what? Loads. The load is being categorized what? Gravity load and lateral load. Fantastic. Then the gravity load will dead load, SDL, light load. There is other load as well, which is temperature. Other load, temperature load. Okay. हम लोग स्विट्जरलैंड में थोड़ी actually. We don't have snow, nothing actually. Correct? Rain, nothing. The pile we will discuss further. Okay. Pile we will discuss when we are going to do this. I'm only talking about the foundation thickness. Okay. Either it is isolated or it is a wrap foundation. Okay. The minimum thickness you have to follow as per codal recommendation 25 cm. But practically I can only go for 30 cm. Even for villas actually you are going for wrap foundation. Right? If there is a basement, what do you do? Correct? You cannot go for isolated foundation if it is a basement, right? You need to go for wrap foundation. Correct? Okay. So gravity load will be classified as dead load, superimposed dead load, light load. Dead load is what? It's a self-weight of structure. SDL is what? Superimposed dead load. What is superimposed dead load?
Block finishes.
Block core
Finishes.
MEP collateral, right? MEP collateral. And block core, different types of block cores are there, right? A.E.X.L, hollow block core, solid block core. Definitely we are not going to use solid block core for the entire construction, right? Either we will use it A.E.X.L or hollow block core. I understand. The first layer will be what equal solid block core, right? Actually, if you are using I can see your face. Okay. But no, except the substation, no one is going to use a solid block core for entire construction. Yeah. Solid block core, no one is going to use. Maybe it is substation actually.
Below, sir.
Yeah, maybe it is MEP. Yeah, anything which is required by MEP actually. MEP, fire rated is higher. Okay. Then because solid block core will take more than 2 hours fire rated actually. Anything which is required by MEP, for the entire structure, this is only peanuts. Maybe not even 2%, 1%. We will talk about the majority of things. Either it could be aerated blocker or hollow blocker. If you are going for aerated, A.E.X.L. If you are going for hollow, 3.5 kPa. Yeah, 3.5 kPa. How about the finishes? I do have different kind of finishes. Either it could be tile, marbles, screed, and there won't be any kind of finishes like car parking actually. There is nothing actually, correct? Okay, in car parking there is no finishes, right? I'll make it very clear. As per authority requirements, so you need to follow minimum finishes for to consider as a marble actually. 2 km per square meter for the marble load. Okay. If you are 100% sure, you are not going to use it anything like marble for entire construction. It is all tiles. Then you can substantiate to the authority. You can make reduction from 2 to 1.5. But you need to show the EV research for the entire architectural drawings. We are not going to use it. The authority is correct. What they are trying to say, once the building is completed, once you got the BCC, okay, then you close the door. Actually, you can change the finishes. Nobody is going to notice. Okay. Okay. Even the inspector also is going to be like, come once the BCC is being like, occurred, right? Actually, that's what they're trying to say. Like, take it minimum load is 2 kPa. Going for MEP, 0.5, 0.5 kPa. 0.5 kPa. Okay. Now, the moment when you're talking about SDL, it is a combination of block work plus finishes plus MEP. The block work is, if you're going for aerated, then 2 plus 0.5, which is 4.5 kPa. If you're going for hollow, 3.5, 2, which is 5.5 plus 0.5, 6 kPa. The difference with respect to block work. Okay, other finishes and MEP it remains so much. You getting point, right? Going with live load, it's a different funda. Okay, different funda. I'll remove this one. Going with live load, if it is residential unit, yeah. If it is commercial unit, if it is office, if it is staircase, lobby, corridor, car parking, gym, mezzanine floor for steel structure. Okay. What else? Okay. For residential building, it is 2 kPa. For office building, it is 3 kPa. For commercial building, it is a combination of residential plus offices. Wherever there is a residential, follow 2. Wherever there is offices, follow 3. Right? In commercial building, might be like, the below 3 floors will be offices. Right? Might be like, completely above 10 floors or 12 floors will be residential. So the above floors full completely will follow 2, and below 3 floors actually will follow 3. Okay. And it is not mandate that you have to follow the entire buildings as 3. Okay. Nobody is going to like force you. The only thing is you need to substantiate the architectural drawing. That's all. Okay. And going with the common area, which is called staircase, lobby, corridor, it is all 4.8. Why not 5? Why it is only 4.8? What is the difference between 5 and 4.5? Only 20 kg per square meter. Okay. The reason it is giving, the code is giving the privilege. Okay. If it is 5 or more than 5, okay, you need to increase the base shear in the combination of the load with the live load. You need to increase the percentage. Okay. When you are talking about the base shear, okay, which is mass, the shear force, F equal to MA, right? The mass is what? Your dead weight of the structure and including your live load. Okay. The live load code is giving the privilege. Code is giving the privilege. When it is less than 5, you can only consider 25%. When it is more than 5 and 5, actually you need to consider 50%. If it is more than 10, then you need to consider 100%. Okay. Because the more than 5 will have only like 2 places, gym and as well as food equal actually. If there is any measurement for the steel structure. But if you are talking about normal MEP load, it will be more than 5 only, like 7, 7.5. Okay. So what I am talking about, just make it the categories actually. Okay, I don't want to confuse you. If it is less than 5, when you are calculating the mass source, you can only consider 25% of live load. Okay. If it is 5 or greater than 5 in the sense, less than 7.5, it is not in the code. It is not in the code. The one which I am saying, it is not in the code. 5 to 7.5, you can take it 50%. If it is more than 7.5, then take it 100%. Okay. Yeah. But what code says, okay, if it is more than 5, directly take it 100%. You don't take it. Because authority, it is not required. You need to take it 100%. 100% authority is required when you do have complete mechanical flow. Okay. If it is a complete mechanical flow, like I do have a pumps, okay, I do have mechanical equipment, then it goes, the load is actually 7.5. Okay. When it is going more than 7.5, then take it 100%. The reason why gym also, which is included 5 kg. Sometimes what happens, the people will include in the base shape for the gym as well. Okay, maybe like there is a cycle track. In the A.E.X.L road, there is one building actually which is called what? Blue Tower. The right hand side, which is very close to Crown Plaza Hotel. Okay, in that, in the 15th floor, we do have jogging track. The floor itself, there is a jogging track. Okay, so what happened? I'm going to take it like all 5 km per square meter actually into the base shape. That's what I'm telling you, don't need it. So you can eliminate from this. Okay, so if it is 7, more than 7, you can consider 100%. 5 to 7, keep it 50%. Less than 5, take it 25%. This is also one of the questions. As per DM. Yeah. As per code, if you want me to say as per code, less than 4.8 or less than 4.8, you don't need to consider any live load participation in the masters. Not even 1%. You can completely omit. Huh?
Less than how much?
Less than 4.8. Less than 4.8. Okay.
Equal?
It is not required.
4.8 also can
It is not required. 4.8 or less than 4.8. If there is anything more than 4.8, okay, I can show you the code. Anything more than 4.8 actually, then you can consider 50% to 100%. It's a classification with respect to MVP load. Okay, it's a classification with respect to MVP load. But authority will never accept it. Authority, what they are trying to say, even if it is like 4.8 also, consider 25% of liability. Okay. Both UBC 97 and A.E.X.L 768. Both. Uniform Building Code 97 and A.E.X.L 760. We're not here to talk about any British code. It's all American code. Okay. I'll substantiate. I'll give you the papers. It's clear, right? Yeah. Temperature load. Temperature load for substructure plus or minus 15, for superstructure plus or minus 20. For steel structure plus or minus steel structure plus or minus 25. Very good. Okay. For steel structure, for Dubai, we need to consider the minimum temperature is what? Plus or minus 25. But for substructure is 15, for superstructure is 20. Ground floor is not going to be considered as a substructure. Ground floor will be superstructure because ground floor slab will be exposed. Below ground floor, like basement 2, basement 1, if you do have number of basement, okay, except the raft foundation, you can exclude the raft foundation, except the raft, everything you can consider because raft you are not going to model in the E.E.X.L. Raft you will be designing the stage. So you can omit because you already consider all the temperature. The whole temperature effect has been already participated in the raft formation. Yeah. So you don't need to consider any separate temperature in the raft formation.
What are the basement walls? What are that we have done?
Everything.
For foundation to ground floor, what are the basement wall? Or
Basement wall you don't need. Only I'm talking about the slabs.
okay, only for the
Only for the slabs. You don't need to consider temperature for walls. You don't need to consider temperature for columns. You don't need to consider temperature for beams as well. I'm only talking about the shell, the slabs.
Wall is required,
which is
right?
going to be expanded. You don't need it. You don't need it.
Below ground.
Below ground, above ground, you don't need it. Don't consider it. If you consider temperature for walls, it will give you huge reinforcement. I'm trying to help you. It will give you huge reinforcement. I'm trying to help you. Codal doesn't have any kind of static actually you need to consider for walls and slabs. The minimum temperature code say actually like 15 to 20%. But this 15 20 is being set by authorities. It is based on the the localized conditions where exactly you are going to design. This is there in DBC code. By building code 2021 actually, they did not mention for the particular elements you have to operate. They have given a very vague actually. For substructure 15, for superstructure 20, for steel structure 25. That's all. Okay. So don't consider the wall. If you want to consider, consider. But if you consider actually it will demand huge increase.
so what are we are doing? There is only for slab.
Only for slabs. So in reality, slab is going to expand actually. In reality, slab is the one which is going to be expanded actually. You getting a point? Okay. But that is what is going to be exposed.
So,
Because of the area.
Yeah. What is the expansion joint? Another question.
Yeah.
Before you are throwing the question, I will throw another question.
I was about to ask that
Yeah.
actually.
What is the limitation of expansion joint actually? What is the limitation of the length of expansion joint?
30 meters.
30 meters. Actually, no, where am I? 35, 45 meters. Somehow very close actually. Somehow very close. Anything? 40. No, sometimes I answer. Okay. As per code, there are different criteria is there actually. I don't want to give you any rough figure. I'll give you the code reference. But as such, I can say 45 meters. 45 meters. Okay. But there are different criteria is there. American code, PCA handbook. Okay. A set of different criteria for the length. Okay. Give me till next class. I will give you. What is the actual length?
Yeah, because we had problem like for the one water retaining structure, they increased the reinforcement to get rid of the joints. Means earlier they were proposing some kind of
Are you
joints.
proposing the expansion joint in draft foundation?
Yes.
Hmm?
Yes.
In draft foundation. How you will propose it?
This what do you say? Embedded that PVC thing.
You don't provide any kind of expansion joint to the foundation.
No, not draft. I mean.
That you are telling how you are going to treat the expansion joint. Correct? How you are going to treat the expansion joint. By keeping PVC cap actually, like aluminium, the one which you are going to keep. How you are going to calculate the expansion joint width? Say 35, 50, 60. So there could be a calculation, right? If you are following maybe 150 story tower actually, then the expansion joint may not be same as 25 millimeter, right? And it may not be same as 50 millimeter as well, right? It requires some calculation, isn't it? Actually? The expansion joint, you will see.
Yeah, this one we had for cycle track also. We had some concrete cycle track. Initially, they were proposing like 20 or something, but it started cracking everywhere. Then they reduced it, and they asked to come up with a calculation.
So you don't have any problem actually, for the below structure, like up to 3 floors, 4 floors, 5 floors. There you will have a problem where there is a maximum drift is damage. Okay, there you do have a problem. Okay. What happened? When the building tried to expand actually, and it tried to displace. Okay, then this tower and this tower is getting collide each other. This slab and this slab actually when it touches each other, then the cracks will start. But when it is below floor, 3 floors, 4 floors actually, you will not have such kind of scenario. Because either you will not have maximum drift, or you will not have maximum the temperature expansion. Okay, when going up actually, you will have the huge when going up actually. Especially I'm talking about drift actually. You cannot say depends on the location, depends on the shape you can say. If you're talking about L shape.
The weather is not good for that.
Sure.
The weather is not good for the housing. That can change of temperature.
Wherever expansion joint has been provided, you are separating the two buildings up, where exactly 2 columns is going to be. Correct?
Then the level, first level, second level also experience that.
That is with respect to architectural norms.
This one like
Maybe you don't need to keep it 45 meters in the 45 meters. I can here and there adjust 46, 44, 43. You're getting a point. So if you're going to propose 45 meters exactly in the middle of room, who will accept? You're getting a point. Okay. Is it clear? Any question asked? I'll make it very clear.
I asked the whole new design the
So that's what I will tell you. Because if I say something now, you will be confused actually. Because delta m1 square, delta m2 square root of. So this is the resultant, what do you call it, the width of expansion language. If I do have 2 towers, take an example adjacent, this tower actually, how much is going to give you the maximum drift actually. Okay. And this tower, how much is going to maximum drift? Say for an example 50 millimeters, this is 60 millimeter, 50 square plus 60 square might be 55 millimeters. Then I need to keep it, the minimum joint width is 55 millimeters. Like you will never understand if I say
Based on
something.
the drift of the two and
Based on the drift, that is defining the expansion joint width. The expansion joint width is being defining by the drift. Okay. The length of expansion joint, which is criteria set by the code. But if you want to follow more than that, follow, but provide the compensating reinforcement with respect to compensating reinforcement.
In that case, if I'm limiting 45 meters, so I'm limiting to 40 meters.
You don't need it, but as per authority, you require it. As per authority. Because as per authority, even if it is less than 45 meters or 40 meters, at any cost you need to consider the. You cannot avoid this. You get it? You have to consider it. The question is that.
So when we are designing the tower,
Hmm.
so we have normally holding floors and the cover.
Correct.
In case of the facade.
Correct. Only one floor actually, or first floor. From second floor to till 20 or till 10th floor actually, there won't be any kind of finishes actually. And you are not going to do for 1 year. Somehow it is stopped. And if you don't consider the temperature, you will have a problem. That is what the authority argument. But the code argument is actually if it is less than 45 meters, you don't need to consider the temperature. If it is more than that, you can consider the authority argument is actually, this is what, when we had a debate actually, this is what they said. If it is stopped actually, then definitely this slab is going to be expanded actually. And where exactly you are having counter the reinforcement.
There is a constraint for the
Right? If you multiply by the area, then you will get the force, isn't it? Wind load, what is the basic wind speed? As per DBC code? 38. Okay. The other parameters we will see. Okay. Seismic load, we will discuss actually while going to the model. Okay. I don't want to give you the rough parameters in order to confuse you. We will discuss the seismic load and wind load. Okay. Temperature we already discussed. And the load combination, we are going to deal by LSM, limit state methodology. Correct? Limit state methodology will be two categories. One is ULS, another one is SLS. ULS is what? Ultimate limit state. SLS is serviceability limit state. ULS, you know that which is going to be governed for the design. SLS which is going to be governed by the serviceability criteria. Correct? Okay. Another one is what? Analysis, right? Analysis. The next one is what? Design. So before design, actually, we do have check, which is called serviceability criteria, serviceability check. Yeah? So serviceability check actually will be defining by deflection, will be defining by displacement, will be defining by drift. Okay. In fact, it is all deflection only. This we have already seen, right? Actually. So deflection, which is related to gravity load, displacement related to wind, drift related to seismic. Now, what is the allowable limit? Span by 240, h by 450 to 500. Okay. This is, I don't want to confuse you. Interstory drift is 20 millimeter, which we will discuss while going to the model. While going to the model, I can show you the allowable drift as per codal recommendation, how to calculate, and what is the DBC criteria, how to calculate. Okay, so I don't want to give you the rough figure here. Okay, but take it these two: deflection and displacement. Make it one thing actually. The building, it is not mandated to govern always either by wind or either by seismic. Okay. With respect to the shape of the building, with respect to the height of the building, either it is going to be governed by the wind or seismic. Okay. If it is a tall structure, you may predict it's going to be governed by the wind. Okay. If it is a high-rise building actually, because you have several criteria are there. Maybe your mass is different, like Dr. Haran actually wished the class, right? Actually, your mass is different. Okay, when you do have irregular footprint, maybe you do have large cantilever. Maybe you have comparatively the difference in stiffnesses actually. Might be in below you do have bigger columns actually. When going small columns, suddenly the columns is stopped. You need to take the new columns actually as a planted columns actually. Okay, these are all irregularity in the stiffnesses, irregularity in the masses. Might be a 10th floor actually. You do have huge load due to MEP actually, right? So which is like MEP flow actually. Okay, so irregularity in the masses actually. Irregularity in the footprint itself. Might be the tower itself actually, which goes like step by step actually. Okay, with respect to architecture. So with respect to those kind of cases actually, you cannot say it is 100% which is going to be governed by the wind actually. Might be in that case actually it will govern by the seismic as well. Okay, but I can say one thing actually, the high-rise building, the one which you're talking about, like 30 to 50 floors actually, 90% it will not fail under wind. Okay, 90% it will not fail under wind, because wind is purely governed by the self-weight of structure. Get it? Wind is purely governed by the self-weight of structure. To check the wind again, there is a combination as per code. Okay. %% of dead load, 70% of wind load, 50% of live load. So you don't need to check the 100% of live load. Okay. In reality, also 100% of live load will not be there at all. In whole slabs, in whole floors, in whole stories. The reason actually, which I told you in the last class, remember, for 1 BHK flat, how many persons have been living, right? 1 BHK flat area is how much? Hardly 70 square meter, right? Okay. In 70 square meter, how many people are living? Maybe 5, 6. Average, if you take it, 480 kg each. So 70 divided by 480 kg, which is 4.8. It will not be less than 1 kilometers per square meter actually. It is 0.8 each. But what you are considering, every square meter, you are going to take the live load as 200 kg per square meter. So in reality, it will not be there. Okay. In reality, the staircase which is empty only. Correct? When there is a fire only, they are going to use it. So most of the places actually, what you have been assumed as per code, you are not going to is not going to be exist in a realistic case. Okay. That is the reason the code is giving the privilege. But still, if you don't want to do this, still if you consider 100% dead load actually, by omitting the live load, still it will be safe. So what I am trying to say, the building, it is very rare to fail under wind. Okay, because the wind where is going to be higher. Where is going to be higher in the wind actually? Only on the top. Okay, if I do have a beams on top floor actually, the wind will be like counter. But it's not like a drift actually. Drift actually, so you will have variation. Might be a 2/3, might be 3/4 actually. So if it is 2/3, 3/4, it will be governed like majority of the floors. Might be like 6, 7, 8 floors actually. So around 8, 9 floors I cannot provide the beams. They are very important. Might be it is all typical actually. If you provide the beams actually, people will have a question. Why I don't have beams like below typical actually? Why you do have a beams? You get a point. So I need to compensate. I need to counter in a different way. Okay, that's a different challenge actually. But wind is very easy. I can easily counteract actually, because I know where is the wind displacement which is going to become. Even if I provide the beams on top of roof actually, nobody cares. I can take it as upstand beam. I can take it as an inverted beam actually, which will be acting as a parapet again. You get a point. Maybe I can go for concrete parapet actually. You get a point actually. So it will be acting as complete inverted beams. So those things will directly counter the wind. So it's all required by stiffness. Correct actually. Here stiffness directly funda is where I have the maximum displacement at wind actually. I can directly have the lack of stiffness at roof. I can provide it. But the problem in the seismic actually, the lack of stiffness will govern the majority of the flows actually. Okay, in between might be 8 floors, 10 floors, 12 floors, 15 floors actually. The whole 15 floors, you cannot give you the stiffness as it is. Maybe as such sudden in between the columns actually, you cannot increase it. Might be the column size comes 300 by 800 or 400 by 1 meters actually. I cannot go from 10th floor onwards 500 by 1.2 meters. It is class B rebar. In splice calculation, you do have 2 rebars, class A and class B. Okay. Rebar same rebar. There is no change in the rebar. The performance of the rebar is different. The performance of the structural element is different. Where you don't have higher forces, where you don't require more bonding actually. Okay, where it is not going to be act as full structural element. The best example is grade slab. Okay, other than that, everything has been you can say structural element. The grade slab is the one actually which are going to use it 8mm dia, 10mm dia, right? Not more than 10, nobody is using. Until otherwise, if you do have heavy load what do you call racking load, or else you use it 10mm. Might it will go for 2 layers actually, single layer to 2 layers. But nobody is going to use it 12 at 150, 12 at 200, similar to suspended slabs, right? Actually, okay. We will not use it class A rebar, which is you are using always class B rebar. Same rebar, huh? Don't confuse yourself. Huh? Only the where exactly you will be using this between the bond, between the loads, between the structural loads. So you are always using class B rebar. Huh? Sometimes in the structural details you will see category 1, category 2. Huh? Okay, category 1 rebar, category 2 rebar. It's all class B rebar. So coming back to the development length question actually.
So what is the difference A and B?
See, rebar is same again. The yield distance which is 460, 500, it is same. Same using the same rebar. So if you are using grade slab 8mm dia, it is also deformed bar. What is 500, 550? It is a deformed bar yield distance. It is not with respect to diameter of the rebar. It is a deformed bar yield distance. Even if you are checking 10mm also, you will get 500. If you are checking 12 also, you will get 500. That is the minimum yield distance what I am talking about, right? What is the tensile strength? I will coming back to your questions. Let me answer this. Let me ask this question. What is the correlation between the yield strength to tensile strength? Yield strength, 1.25 times of 1.25 times of yield distance is equal to tensile. This is also one of the questions. 1.25 times, 25% higher than your yield distance, which is equal to tensile strength. Okay. Now coming back to your question, same rebar, but if you are using where exactly you require less bonding, less load interaction, then you will use it class A category. In class A category, the lap splice it is less than class B. Only the lap ratio is this.
Yeah.
Okay. Or else you will go for class B. Class B. Plus. AC some whatever I am saying, it is all code voltage. AC sound 16. Even this code also. AC 31890. AC 31890. So there are equal two kind of equations there. When you want to use it as a hoop, then you have to use it the separate equation. Okay, I can show you. Or else, if the shear wall length is higher, then I can only compensate with the straight rebar as LD. Okay, straight rebars. So you don't need to take it what equal form. The similar funda which you are going to follow in the raft as well. This is the LD. You don't need to take it all the way. Getting a point. 4.5 meter thick raft actually. Why should I take it all 5 meter of my starter bar till edge? Okay, so you can only take it as what? LD. Okay. This is tension LD. There is no compression. Because in structural element most of it is tension lap only. Compression lap is very less. Okay. Compression lap where you will get it actually?
Columns?
No, in the beams as well actually. In the beams as well. In the mid strip of top, you will have a compression lap actually. Right? This is the beam. Then my bending moment is like this, right? This is the compression actually. Right? And this is the tension, right? This is the tension, this is the compression, this is the tension, this is the compression. The compression lap will be here. Yeah? That's the compression lap. Wherever the bending moment is there, it's all tension lap. The moment which is indirectly induced by the tension force. Okay. Showing this equation. AC 31890 Table number 23.4.2.3. Okay. 4.2.3. Yeah. There are two set of equation. There are two set of equation for development length. This is not for hook bar. This is for straight development length. Hook bar, there is a separate calculation is there. There is a separate equation. This is for straight. But does it mention the straight actually? But where the hook, it is mentioned directly hook. There are two kind of clauses there. When the clear spacing of the bars, okay, if it is not less than dp, which is diameter of the bar, or clear cover at least diameter of the bar, or the clear spacing of the bar 2 times of diameter of the bar. Okay, where exactly you will have? You will have always in the columns actually, because the columns you will have more reinforcement actually. When the spacing between the rebar is less, you're getting a point. Might be you will have 25 millimeter, 30 millimeters actually if it is bundle bar. If it is more rebar, in such case you will use it this equation. You will use it this equation. If not, say for an example, I do have sufficient spacing if it is more than that actually, more than the 2 times of diameter. Say for an example, if I am using like 32 millimeter, then if it is more than 64 millimeters actually, then I will go for this equation. Okay. The only difference is equation is what? This number, this factors. 2.1 here, 4.1 here actually, and this is 1.7 here, 1.1 here actually. Okay. But rest all the epsilon t, epsilon s, epsilon g, it is all one actually. Okay, but still I wanted to show you. Okay. This is the, what do you call it? Epsilon value, epsilon g, epsilon s, epsilon t. Okay, let me zoom it. Okay, here. The lambda also it is there, but lambda it is one for normal weight concrete. Epsilon g with respect to grade of, because which you are using like grade 420 in the sense. Don't consider this is 420 millimeter square. I will show you this as well. Mostly. Can you see the grade 420 which is equal to 475 yield strength, 470, which is very close to 500. So what you are using is yield strength which is 500. So don't consider if it is grade 420, it means like 420 MP. But this is as per US unit, American standard actually. Okay. So I'll go back to like same development length. Yeah. Yeah. So this is the table. Then we are going for further parameters actually, which is epsilon. This is also one. Epsilon E for uncoated reinforcement. Okay, this is not epoxy. What we are using normally uncoated reinforcement, which is also one actually. And epsilon S actually, mostly our rebar is like more than 20 millimeter there. What we are using in beams and columns actually. Also it is one. and epsilon T more than 300 millimeter of fresh concrete placed below horizontal reinforcement, in the sense actually beams. The horizontal rebar actually of the slabs, okay, if it is a difference of 300 millimeters, say for an example there is a beams, there is a beams actually of 300 millimeters, okay, then you will use it 1.3. If not, I'll go for 1 actually, okay. So most widely we will use it as 1 only actually. So I'm just trying to understand. This equation is called standard hook. Can you read it? That's what people are misunderstanding actually. There are two kind of equations there in the code. Believe me, this is your strength. What I'm showing this equation actually, don't take it lightly, because when you are been there in the position, you can fight with the consultant for the development level as IDEA. Even you can fight with the what you call municipality as well. It's not fighting actually. I'm telling it's a healthy argument actually. In a kind of to substantiate things. Okay. Maybe the people are misunderstanding that you do have only one development length calculation. You do have two set of combination for the development length. One is for the straight, this one, note on table, note on the table, ACA 31819, the table number 25.4.2.3. This is for the straight. The another one is for hook. Another one is for hook, which is 25.4.3. Okay, this is not a table, this is the clause. The clause 25.4.3. If you are using straight, the L extension here, can you read it here? The standard hook for stirrups, ties, hoops include the specific inside bend diameter, the straight extension length. It shall be permitted to use a longer straight extension at the end of the hook. The longer extension of this L extension, shall not be considered to increase the anchorage capacity of the hook. You're getting my point, what I'm trying to say actually. If you're using the straight development length, okay, still if you want to bend it this 200, 300 millimeters, the extra I'm talking about in terms of foundation, the example actually, okay. This 300 or 400, it is a standard of 12 times of diameter of the beaver. The one which you are talking about, the minimum, no, 300, 250, it is not standard. The standard is what actually? This is the L extension, which is 12 times of diameter actually. 12 times of with respect to diameters. Now people are rounding up the figure actually. If it comes to 225, they will make it 300 millimeters. Okay, that's the extension. If you want me to say more clear, I'll show you this 12 times of diameter as well. Here, can you see it? Here, most open. Can you see it? The straight extension LXT is 12 times of dB. You get your point, right? 12 times of dB. 12 times of diameter of the rebar. For all the rebars, this is common. Let me go to the next page again. Yeah. So there are two sets of equations. One set for the straight, another set for the hook. Okay. Now coming back to the splice. Yeah. This is for headed deformed bar. Headed actually. Headed is what? Can you see it? This one. The headed is not straight actually. So what happened at the end? I mean, they will make it the same rebar actually. They will make it as head edge. Okay. This only few suppliers are working on it. I can say one of the suppliers is called Pico. Okay, they already got a patent actually. So any kind of rebar, if you ask headed rebar, they can just supply it. Okay, at any length, maybe 4 meter, 3 meter, 2 meter actually, which you don't have the place which you can take it as a bend edge. Okay, at the place you can maintain the development length, then I can use this equation actually to fulfill it. Can you see it? 31 root of FC dash. This is deformed development length for the headed deformed bar. Can you read it here? Do you want me to bigger size? Yeah, here. Can you read it here? Okay. There are three sets of equation actually. One is for the straight. Okay. Another one is for the hook. Third one is for the headed. Headed normally we are not using it. Huh? I'm telling you. Where you do have a problem, sir, in terms of congestion, in terms of you don't have place like to maintain the LDH. Okay. In that case, actually, we are going to use the headed bus. Okay. Now coming back to the deformed bar, sorry, what do you call it? The splicer. Yeah, here. Here. Can you see here? The last splice actually, which is 1.3 times of LD. Can you see here? Okay, 30%. I can show you in the what do you call table as well. This is graphical. Huh? I remember this table number. Yeah, here. Can you see the table here? Yeah, here. There are two criteria is there. The A.E.X.L provided divided by A.E.X.L required. Okay, what is A.E.X.L provided actually? Whatsoever it is required from design, no one is going to follow exactly bottleneck, right? You will increase little bit actually. Might be it is 100, might be it is 200, might be it is 300 actually. With respect to diameters and spacing actually, what exactly practically you are going to use it, right? Actually, might be it is required in design actually T12 at 165, but no one is going to follow 165 spacing, right? So what I'll do, I'll go for 150 each, right? So instead of 165, I'll go for 1. If you're providing 150 mm, then A.E.X.L provided is bit more each, correct? So when your A.E.X.L, the ratio between A.E.X.L provided to A.E.X.L required, if it is always less than 2, huh? No one is going to provide greater than 2, first of all. Huh? Might be it is 10%, 20% extra, or 30% extra, or 50% extra, or maybe 100% extra, but no one is going to provide greater than 2 times of A.E.X.L required. Okay, so always which will be in the second class one. So can you see class A and class B? Okay, in less than 2, class A is not going to be applicable at all. It is only class B. Can you see here? Only class B. Class B, either it is a greater of 30% extra of development length and 300 mm, whichever is greater. Okay, which is 1.3 times of LD and 300, whichever is greater. You get your point, right? This is a straight funda. This is a straight funda for the splice. But the splice, it has a correlation with the development length. The development length which you are going to calculate with this equation, remind me in the next class. Actually, I will give you the Excel sheet. Okay, you can only type your diameters and the grade of concrete and the yield distance. Automatically, you will get calculation for the development length. Okay. With respect to the grade of concrete, with respect to the yield strength, actually, automatically the Excel sheet will calculate your development length. Any kind of rebar, any kind of concrete. See, I don't have time to to do this calculation. I'm telling you people actually, you don't have time to do this calculation. As such, I can show you the what you call equation to just increase your professional growth, right? Actually, personal growth. Say for an example, if someone comes actually, you can make an argument that is. You have been misunderstanding that there are 3 sets of equations there. So the moment when you show this kind of things actually, the people bit of hesitate to talk to you. You get your point. It seems like you know the things. I cannot bluff in front of you. You get your point. And in addition to this, if you say table number 25.4.3.2, he will go home and he will give you the call from there. You know, instead of talking to you like face to face, the moment when you say like, you know, according to the table 25. So it means what? He knows this. So you're not bluffing this. The moment when you're giving the authentic information reference from the code with respect to the table, with respect to the class, with respect to the AST actually, what is the correlation between the splice to development length? And the development length, I do have like, you know, three kind of equations. One is for the straight, one is for the hoop, another one is for the headed ones. Okay, I don't have place. See, there are some kind of consultant actually, like, you know, who doesn't make like, you know, sense at all, and they, like, you know, the kind of things actually which they will be like, you know, adamant in the sense. Okay, might be it's kind of design and build job, or might be like, you know, some inspector actually, like, you know, will be forcing you. Might be there is like, you know, big shear wall length actually. Okay, unnecessarily will ask you like, you know, no, take it, the whole rebar to bend. You getting your point? These things actually, when you will have it, I mean, not in terms of execution, mostly 90% you will have it in the shop drawing stage. When you are submitting the shop drawing, the consultant will review the shop drawing, he will give the comment. Okay. Indirect cost of this, which is much huge, indirect cost, because this goes like, you know, 100 plus 200 slabs and development, and it will be like, you know, using everywhere, right? It's labs, you don't need to say, it will be like, you know, using everywhere. So when you put like, you know, the shop drawing stage, you're discussing with the consultant, these kind of scenario, but until if it is remeasurable contract, it is gainable for you. If it is a lump sum contract, you are going to lose. Remeasurable is what? Again, the remeasurable clauses, if anything, if you have been like, you know, increasing more than IFC drawing, it is not remeasurable. This is contractor who is going to be increased. But if the engineers who is going to be comment, engineer in the sense consultant engineer, who is going to comment on the shop drawing, you need to increase, then it is remeasurable. Because he himself is commenting on it. But at the same time, if you are increasing, it is not remeasurable. Okay. Coming back to the other question, actually, two questions is finished. The third question is what? The shear reinforcement diameters and spacing, do we need to follow? It is exactly same in the foundation. First of all, you need to understand there is a neutral axis zone actually. Okay. This is my raft, right? Actually. Okay. And this is what? This is what? Stress strain diagram, right? Okay. This is what? Correct? Okay. And this is what? Neutral axis, correct? Neutral axis above in the certain portion, this and this actually, it is almost zero. Okay. And very close to the stress chord, very close to the strain chord. This is different. This is varies actually. Stress is not always top, strain is not always down actually. With respect to the moment actually, again it varies actually. Okay. Let's say this is stress chord, this is strain chord actually. And very closer to the stress chord only you will have a problem actually. Very closer to the strain chord only you will have a problem because the maximum is here actually. Okay. But as such, if it's close to the neutral axis actually, it is almost like, you know, the decimal from 0 point something. Okay. So if you have been dumping the reinforcement in the raft in between actually, no use. Okay. This is another question. Say for an example, I do have huge rebar actually, maybe 24 layers. Okay, 24 layers. In that case, you need to understand. Okay, 24 layers. So I can even put the reinforcement here, right? Actually, in the middle actually. Correct? But there won't be any kind of useful because you are dumping the reinforcement in neutral axis. So either you need to provide in the stress chord or in the strain chord. Even if you keep on increasing from the stress chord actually, as the number of layers, what happens? Your effective depth is going to reduce. If your effective depth is going to reduce, your reinforcement is going to be like, you know, shooter up. Because the AST which is directly governed by the effective depth. You get your point actually. Okay. Another question is what, I mean? Now the horizontal reinforcement. Since there is no shear, there is no moment here actually. at this portion actually, then why should I provide like what do you call the same spacing, same what do you call actually, the diameters do we need to follow for the starter bar actually. The starter bar horizontal reinforcement is only providing for two reasons. One is for confinement, another one is for lateral stability of this rebar actually. If I don't provide anything actually, the rebar will not be stable, right? So I need to provide it. Okay. Usually they will give you the thumb rule for minimum 3 diameters, 3 stirrups. This is something like in a site language they used to say. Provide 2 stirrups, 3 stirrups. Okay. There is a clause here. Okay. I need to search this clause. Can you see here class? The ties, which is shear reinforcement class. Clear spacing at least 4 by 3 of the aggregate. This is leave it actually. Okay, this is very minimum. The center to center spacing shall not exceed at least 16 times of diameter of the bar, which is longitudinal bar. Longitudinal bar. 48 times of the ties bar. 48 times of ties reinforcement. Either it could be like 10 millimeter. And smallest dimension of the member actually. Okay, if it is 200 by 1 meter actually, then at least it is 200 millimeters. Okay, this is I'm talking about like the spacing between the what do you call stirrups. And the spacing you don't need to increase anything more than the development range. If you are using like LD, then I can only provide the stirrups between the LD. If it is 2 meters, say for an example, maybe I'm using 40 millimeter diameter. Let's consider like 50 diameter. So which is 2 meter, right? LD is 2 meters. So in this 2 meter, you don't need to follow like what do you call 300 millimeters or 400 millimeters or 100 millimeters spacing what you do have. So what is the spacing you can go for? This is the spacing. Till to the 2 meters away. Either you can go for 16 times of diameters. Okay? 16 times of diameters how much? 16 640, right? Okay, or 48 times of 576, right? Actually, right? 640 or 576, and smallest dimension of member, whichever is greater, actually. Smallest dimension might be like 300 millimeters, the wall width. Okay, then I'll follow only 300 millimeter width. Okay, with only the spacing is how much? Till to the LD. You're getting a point. But what people used to do, because we have seen the shop run, that's what I'm telling you. They will follow the same diameters, same spacing. 100 millimeter spacing, 100 millimeter spacing. Okay, this is two kind of things. Either you are literally wasting the rebar actually, okay, which is unknowingly like in terms of you cannot substantiate even technically whatever the consultant says you are following, or whatever the what do you call the DM inspector authority actually, like sometimes they used to they install like it's a very difficult thing. It is not about like you cannot complain. Okay, complying is different actually. Say for an example, in terms of site, whether you've been executed all the reinforcement. Do you think it is easy actually going with again to fixing the rebar at the bottom layer, top layer? Top layer, imagine like 12 layers. Starter bars is already fixed actually. You already provided 4 bars actually, and you got already the approved shop done. Authority is authority, right? Actually, they'll come and ask you anything. They'll ask you to fix. If in case they ask you to fit actually, how difficult it is for for all the columns. Making the stirrups is one challenge. Another challenge, execution is another challenge.
So this one is the height up to how much you have to add shear base.
LD.
Okay.
LD. Only the development length. Only the development length. If my LD is 2 meters actually, this is what I'm telling you. Might be your shear wall width is 400 millimeters. Then I'll follow 400 millimeters actually, only 4 bars. 4 bars. Might be your tie spacing and above for such kind of shear wall, maybe low 125 millimeter spacing. 12 millimeter. I don't need to follow 125 millimeters. You can use the same diameter as this, but you don't need to follow the same spacing.
You don't have to follow same spacing
For
above the LD.
Exactly.
Means, for example, initially we will have ties at 100.
Yeah.
Then after the LD, then
That is fine. That is you are compensating the actual shear. Where exactly you are working the shear. So you know something. I'll tell you. I'll give you another scenario to make you a better understanding. Okay. This is my beam, right? If I want to draw the bending moment, I will never start from here. Huh? The actual moment will be starting from here, right? Isn't it? Because this is a stiff element. Even if you use any kind of software program, it doesn't start from here at all. Okay. Theoretically, you might say, because theoretically I am pretending this as support. Huh? Then I am taking like, the curve. This is like this or like this, whatsoever it is. If it is fixed terming, then I will take the moment. If it is simply supported, I will take it as 0. Okay. But the moment when you are talking about like in terms of support actually, I will take the moment from here to here. I will never start from here. You get the point? The similar funda for the raft here, the columns actually, then the shear is starting from here, right? Okay, that's what you are following, like to compensate the shear actually, you are going with this, isn't it actually? But right below here, why should I? This is only for the purpose of confinement and the stability of the rebar actually. Right?
This clause is mentioning about the one below the foundation.
Minimum ties actually. Minimum ties requirement. Minimum ties with respect to space. See, code will never give you direct answer. First of all, you need to understand. Code will never ever give you direct answers. The one clause which I read it actually, remember, even in the 12 times of diameters, the straight extension is not going to give you the additional anchorage length. So where is this clause? The clause is very small letter right below the table. You are getting a point. Okay, but people will leave this line. Will take these 12 times of diameters, will insist you because they did not read like the line which is right below the table. Where it is not going to be applicable also is there because you do have 3 equations. Straight LD, if you want to still provide the the hook, that is 12 times of diameters which you are going to provide. Like foundation, I am going to take it LD. Whatever you say is 300 millimeters or 250 millimeters, right? If I do a massive raft, then I only go for like only LD. But separate equation. If I go for like the hook, which I am going to calculate additional to this, the length actually. I'll show you another thing. Planted columns, right? Okay. Or let's say, first of all, we will not talk about the planted column. We will talk about the column termination. Huh? Column termination, right? Okay. Yeah. Column termination. Column is stopping at this level. Okay, maybe like I have new columns is going to stop it, but this column is going to stop it at this level. You're going to take this reinforcement, right? You will bend like this, or you will bend like this. Why? Both are same, right? You will bend like this, or you will bend like this. Like this. Or like this.
Usually it's like this.
Why? What kind of differentiation which I am going to get it? It's basic, right? Column termination is quite often, right? planted column, at least like you can see, it's a kind of 40% with respect to towers, yeah, with respect to high-rise building actually. Okay, maybe. Yeah. If there is no planted, there is no planted.
Reduce the concentration of the load.
Better shear performance.
This is all we talk about, right? Actually, in the manual calculation I shown to calculate the effective height of the columns, right? Effective height of the column. When you're talking about simply supported, the bending which is going to be start from here to here, right? The full height of the columns, right? Actually, when you're talking about fixed connection actually, if you don't release in your structural model, fixed connection is what you're not going to release it actually. If you don't release it actually, it will consider as a fixed connection in structural model. Don't consider it is going to take it as a pin connection. The pin connection, either you need to assign the pin support in the base or at any other element actually when be column or like beams which is connected to slabs or beams which is connected to columns. By default which is going to be assumed as fixed or you need to release. You need to release the moment actually. Two different conditions. If you are going to assume as a pinned connection actually, stress concentration is correct actually, then I don't need to bend it like this way. Then I can take it like this way. This is pinned connection. When you're talking about fixed connection actually, it has to be like this. It has to be like this. On either way. You want me to show the class? No, I'm not giving the vague answer. I'm not giving the vague answer. I'll show you the clause actually as per the code.